Hello, everyone. Welcome back to the Architecture Weekly YouTube channel. And today I'm taking another interview, this time with Vlad Khononov. Welcome. So Vlad is author of several books, including Learning Domain-Driven Design. He's speaking a lot at different software conferences, and he's talking... One moment. And and he speaks mainly about software architecture, domain-driven design, bounding contexts and all that stuff. So yeah, hello.
Hey, thanks for having me.
Yeah, super heavy. So I introduced yourself, but I think it pays some attention to, to make the introduction yourself. So please go ahead.
Yes, so I'm mainly known for speaking on domain-driven design and writing about domain-driven design. The latest book is Learning Domain-Driven Design, previous one, What is Domain-Driven Design? And the next one has nothing to do with domain-driven design. It's going to be called Balancing Coupling in Software Design, and hopefully it's going to be the last book I'm ever going to write.
You're not enjoying writing books?
Oh, no.
Okay.
Definitely not.
Okay,
Definitely
that
not.
might be a hard labor indeed. Yeah, okay, so basically the main topics you're speaking about, domain-driven design and software coupling. Well, we will try extensively to cover the first one today, and if we still have some time, maybe we will touch on coupling as well. So, okay, so the first question I want to ask is that, developers this day are so excited about the technologies like, microservices, micronauts, Kubernetes, Lambdas, clouds, and all that stuff. And when you speak with developers, they're like, I want to try this thing because, like, first of all, they want to play with a new tool. And second, they want to put some lines on their resume so that it looks exciting, right? But the developers are mainly like people who help the business making money. And, my question is how much a developer should care and know about the business itself rather than the technology?
Yeah, that's a great question. So the more the software engineer knows about the business, about the problem they're solving, or rather addressing by building the software system, is going to be the engineer is more valuable for the company. Now, of course, you cannot expect a software engineer to be a domain expert in every company they're working for, because, well, if you're changing a job every couple of years, it's going to be hard to catch up with all those different types of business domains. And by the way, that's how our industry started. In the beginning, what they did is they taught domain experts, business people, to write code. That worked, but of course, that didn't scale. So right now, we're software engineers. Our expertise is building software. Don't know about you, but I got into this profession because I wanted to work with computers, not people. And that was the biggest lie of this industry. Because eventually, to be successful at software engineering, you have to be successful at understanding people's needs, what they need to achieve with that software. And that's why I'm so passionate about domain-driven design, because this methodology provides you tools and techniques for bridging that gap in understanding of the business domain between business people and software engineers. And it is doing that without forcing software engineers to become domain experts. It's not possible. So instead, we have other tools like building a model of that business domain that's going to focus on the purpose of the system we're building. Instead of, if you're working for a medical company, well, requiring a medical degree would make hiring software engineers a bit harder.
Yeah,
than
indeed.
It is right now.
Indeed. I remember my first job as a Java backend developer, and it was for a small company that was helping, investment banks to, expand on their portfolios. So I had to understand at least a little bit how this, investments through insurance work, what are the bank accounts, how they, work in a nutshell, how banks speaks to each other, and so on. Yeah. Okay. But business is typically a very big and complex thing because it's like its nature, right? Because if business is easy, then everybody will be doing that. So business is hard. But how the developer can learn this thing, right? So how the business can be restructured into parts in order for the developer to grasp it.
Yeah. So the complexity of the business domain can be addressed in the same way as other types of complexities by dividing it into smaller chunks and making sense of them individually, and then making sense of the whole system, how those smaller components work together to achieve the overall goal of the company. And if we are talking in terms of domain-driven design, then we have a business domain, which represents the whole field that the company is working in. For example, for Amazon, that would be retail and cloud computing. But of course, there are multiple companies working in the same business domain, but that doesn't mean that these are exactly the same companies. They differ from one from another, and the way they are trying to differentiate themselves in domain-driven design represented with the notion of subdomains. A subdomain is basically a unit of functionality, a coherent set of use cases that achieve a particular business goal. That's subdomain. And according to the idea, there are multiple types of subdomains. We have core, supporting, and generic subdomains. A core subdomain is something that differentiates the company from its competitors. This is how the company is aiming to make profits. That's how it aims to provide a better service to its customers than its competitors. These are core subdomains.
Let's have a small example. Like, can you pick a company and tell like what part of its business would be a core subdomain?
You know what? Let me ask you. I have a friend, and this friend of mine is building a website, an online shop for his wife. She is a jewelry designer. So we had this discussion of, if we were to analyze that business of your wife from domain-driven design standpoint, what would be the core subdomain here? Is it the website you're building, or is it something else?
Well, to me, it sounds like the jewelry itself is a core subdomain, right? This is the product that she's selling.
Yeah, exactly. Yeah, exactly. That's the core differentiator. That's what differentiates her products from other companies, unless they're copying from her, but that's another topic. So that's one example of a core subdomain, a unique design. In broad terms, whenever you encounter intellectual properties, things that you don't want your competitors to copy, that's probably a sign that you're talking about a core subdomain. In my trainings, in my books, I usually use the same company for all the examples. The company is called Internovus. Right now, it's a brain dead company. It exists only in books, but it doesn't really exist as a business. So I'm free to use whatever I want from that company to demonstrate the various tools from domain-driven design. So in that company, a core subdomain, one of the core subdomains was our own CRM system. Now, it sounds crazy. Hey, you have Salesforce, you have dynamic CRM, whatever. You have plenty of tools that provide this CRM functionality. Yet, we wanted to implement it ourselves. And we did it because none of these existing tools provided the customizations we needed to optimize the sales flow. Our business people had a unique idea how to optimize the flow of making sales, And the only way to implement it was to build our own CRM system. Sounds crazy, yet it worked. So that's one example of a core subdomain from that company. Another one
But
would be
yeah, I'm sorry. So basically, you're saying that might be several core subdomains, right? So there might be subdomains about like some intellectual property of the product, which the company is selling, and some unique tools that streamline, for example, sales process or delivery process or something like that. So what comes to my mind, correct me if I'm wrong, it's, for example, for, again, a retail company that, I don't know, sells the covers for iPhones. So they might, so one core subdomain might be the covers themselves, right? The manufacturing or whatever. And another thing would be like logistic, because they, for example, have some unique process of delivering those things, because like they are dealing with tiny, lightweight things that they can batch together or whatever. Is it a correct understanding?
Yeah, definitely. Whatever gives you a competitive edge over your competitors, that's a potential core subdomain. And from logistics standpoint, well, we have Amazon. Their logistics is so effective that usually it makes no sense in trying to look for products on another website, because you know in advance that that's the fastest way to get it. So that's definitely something that can be considered a core subdomain.
Okay, cool. So you mentioned other domains like generic and supporting subdomains. So what is the purpose of the generic subdomain? What are the examples of those?
Mhm. Yeah, let's go back to the example of Internovus and our CRM system. If we were to decide to use an existing off-the-shelf solution like Salesforce or something, that would be a generic subdomain. A generic subdomain is a solved problem. It's a problem that somebody has already invested time and effort into providing an optimized solution for you. So unless you can do a better job, it makes no sense to try to implement it yourself. And poster boy example of not implementing a generic subdomain yourself is encryption. Well, coming up, unless you're an encryption security oriented company, coming up with your encryption algorithm is usually a terrible idea. You will be better off using an existing solution, an existing algorithm. So that's a generic subdomain, a solved problem. A solution that you can use and your competitors are using the same solution. It doesn't provide any competitive advantage, neither to you nor to your competitors, but at the same time, it frees your time to work on what really matters, your core subdomains, instead of coming up with an encryption algorithm. And believe me, I saw some crazy things like a company that compiled their own version of a Postgres database, and they backed in some business logic in there for some reason. That's a good way to waste your time and money.
Okay, that sounds like a crazy idea, right? So unless you're not doing databases like creating your own fork of a database just for sake of what's, I don't know, not invented here, maybe.
Yeah, that's a good way to ensure job security. Whoever did that, it's going to be hard to find a replacement for that person.
Oh, yeah, exactly. Okay, but the question that comes to my mind is that, well, let's say we're talking about bolts, and in Bolt we have plenty of different SaaS solutions. So we're using Lipsum to gather the feedback. We're using Greenhouse for hiring and so on. So do I understand that right? That like us buying the Greenhouse or using it as a software as a service basically means this is a generic subdomain. So there's no competitive advantage, but still we want to hire people. So we're using like a software for a solved problem for that.
Mm-hmm. Yeah, exactly. That's the idea of a generic subdomain. If you are using an existing solution and you are okay with your competitors using the same solution as well.
Okay, nice. But then what is the difference with the supporting subdomain then?
That's the trickiest one. And it's tricky because just as a core subdomain, a supporting subdomain is something that you have to implement yourself. There is no an off-the-shelf solution available that you can use. However, like generic subdomains, supporting subdomains provide no competitive advantage. So the easiest way to define a supporting subdomain, in my opinion, it's if a core subdomain is an interesting problem, a generic subdomain is a solved problem, then a supporting subdomain, it's a boring problem that you're forced to solve, but you're not really interested in. If there would be an off-the-shelf product, you would jump on it. You would prefer to take and use it instead of implementing it yourself. And by doing that, it wouldn't affect the competitiveness of your company, of your business. So usually supporting subdomains, they are there to support the implementation either of a core or of a generic subdomain, something that you have to implement yourself. And usually, if we compare them to core subdomains, because these two types have to be implemented in-house, then core subdomains are usually way more complicated. There is more complexity there. Whereas supporting subdomains, they are more straightforward. These are CRUD interfaces for entering data, ETL operations. Usually the complexity of the problem you're solving in a supporting subdomain is way lower, something that is more straightforward. And again, ask yourself what would happen if an open source project would come up tomorrow implementing exactly the same functionality. If that would make you happy, that's a supporting subdomain. If that is going to make your business people scratch their heads, then it's probably core subdomain.
Okay, what are the examples of supporting subdomains? Is it like sending mails or, I don't know, persisting data into database? What exactly should it be?
Yeah, so for example, let's go back to Internovus because, come on, I have to use that example. So that was a marketing company. And one of the systems that we had was a system for managing creative materials, banners, landing pages, all that annoying stuff that is that we are bombarded with on the internet. So we needed a catalog for all those creative materials. From the business logic standpoint, it was simple CRUD interface. The designers would log into the system, upload their files, and that's it. And so they could create a new one, update an existing one, mark one as inactive, and maybe a search for querying the existing creative materials. That definition sounds pretty straightforward. It's a CRUD interface. So that's a typical supporting subdomain. Now, what's interesting is that later on an open source project came out implementing the same functionality. So we said, oh, so we can kill this code. And we did that. And it made us really happy.
Okay, sounds awesome. So basically, you're saying that if we're taking this example of the creative work catalog, that you couldn't just use like S3 or cloud storage for storing file because you had to have some additional functionality on top of that, like search or, I don't know, status and something else. But it's basically very, very simple and straightforward. Just, store the status in the DB and that's it, you're done. And still, so you still have a problem. You don't have any components to implement it. And then you need to write some boring and simple software to have it. Then it's a supporting subdomain.
Mm-hmm.
Okay, yeah. Nice. I understood it finally. even me. Yeah. Okay. So I think we're good talking about the subdomains, unless you don't want to add anything like any heuristic that help you to distinguish between those subdomains.
Yeah, so there are multiple heuristics for identifying them. The first one would be about competitive advantage. Does this functionality that you're implementing provides an additional competitive advantage to the company? If it does, that's going to be a core subdomain. If it doesn't, then it's either generic or supporting. And then you have to ask another question, whether an existing solution exists or not. If you have one, generic. Otherwise, it's a supporting one. Another way to distinguish between them is to evaluate the complexity of the solution, of the implementation. So if the complexity is high, usually it's going to be either a core or a generic subdomain. Supporting subdomains there, usually they are simpler. So the next question is whether you can use an existing implementation of that complexity or not, whether you want to use an existing implementation or not. If you don't want to use it, even if it exists, because you believe that you can do a better job, that's a core subdomain. If not, it's generic one. Now, it's important to remember that even if you categorize something as a core generic or supporting today, doesn't mean that it's going to be the same tomorrow because things are changing. Your business may evolve over time, and whatever was considered a generic can become core, or core can become generic. And all combinations are possible.
Yeah. So basically, this is what happened with Amazon, right? When they decided with their cloud computing manifesto, when they decided that, hey, we need to scale up our platform, and they basically invented this cloud service, and it became the core subdomain because they widened their expertise in this and offered it as a separate service. So this is an example of, I believe, the generic subdomain moving or supporting one, generic one. Supporting moving into a core subdomain.
Yeah, that's a good example.
Yeah. Okay. Super nice. Okay. Let's go further then. So basically, like we started with discussing developers and that they need to understand the business in the first place in order to be successful and useful for the business. And then we understood that there are different types of business areas and they bring different value to the company. Right now, we need to understand how we can use this information about the business structure to map this into the informational system. So how this DDD can help software architects and developers to build good technical systems.
Mm-hmm. Yeah, that's a great question as well. Yeah, so domain-driven design, I like to expand that title of the methodology to business domain-driven software design. Or in other words, software design is a function of a business domain. There is no perfect architecture that is going to be perfect in all cases. It all depends on your specific context. So domain-driven design provides us various tools for translating that knowledge of the business domain into software design decisions. And these software design decisions, they take place at multiple levels. The first one is more strategic one. So when we are talking about different subdomains, we can already make some decisions about how they're going to implement it. The generic one is not going to be implemented. For a core subdomain, you probably want to assign the best people you have to work on it because that's where the complexity is the highest. Supporting subdomains, on the other hand, this is something that you can outsource, for example, to save some time, or you can use it as training wheels. If you want to, for example, try new technology, new pattern, new methodology, whatever, supporting subdomains, usually they entail way lower risk than compared to core subdomains. So they make this perfect playground if you need to test out something new.
Yeah, speaking about the playgrounds, I remember that during my time in EPAM, we had a lot of new people come into the company, and we had people that we taught software development, and we had a lot of internal systems. For example, a telescope. It was kind of a tool to manage employees, projects, all that stuff. Basically, it was set of CRUD operations on those entities. And we had extensive projects that we taught our new people, coming people, to do software, right, with those projects. So those were supporting subdomains, but that was a great polygon to try out new things, new technologies, teach people, and so on. We even used that to improve the skills of architects, because they could, enter the domain and, design some solution, make some mistakes on a safe field, right?
Yeah, actually, I'm doing it myself right now. because I want to get familiar with a new technology stack that I never worked with. And yeah, I want to try to implement something. I want to implement an event sourcing based implementation, but I have enough complexity already with the new technology stack. So I picked the supporting subdomains to start with, to get a sense of it.
Okay, okay. So the first thing you said is that you basically can pick different people for different domains, and you mostly want to concentrate the talent into the generic into the core subdomain because it brings the competitive advantage. Okay, what other clues? Like, this is more like people management, right? So what are the technical clues that DDD can give us?
Yeah, so let's say that we're going to the next step of implementing it in code. So we have to implement the business logic. We have to pick an architectural pattern for our solution. And again, domain-driven design can help us here, because if you're aware of the different options for example, for implementing the business logic, for modeling it, and for architecting the whole solution, then you can draw some heuristics from the knowledge of the business domain to the solutions that are going to be more useful in each context. So if we're talking about business logic, then I like to use Martin Fowler's terminology, the one he proposed in his book, Patterns of Enterprise Application Architecture. In it, he defined a number of patterns for implementing business logic: transaction script, active record, or another one, table row, but I prefer active record, and domain model. So transaction script is the simplest one, simple, straightforward business logic that you don't need to go crazy with abstractions, etc. Active record is for cases where the business logic is simple, but you have more complicated data structures that need more elaborate mapping to their underlying persistence mechanism. Domain model, this pattern is for cases of high complexity in the business logic. And that's the pattern that was originally defined by Martin Fowler, but the more elaborate way to implement a domain model was described by Eric Evans in the original domain-driven design book. All the aggregates, value objects, repositories, etc., all these building blocks are a part of the overarching domain model pattern. And we have an extension of domain model with event sourcing. I usually call it event-sourced domain model, because these are the same building blocks. We're just using event sourcing as our persistence mechanism, as our way for modeling the changes in the state. Now,
okay,
we have
so basically you're saying that DDD can guide us and suggest the patterns that we may apply in different subdomains. Is that correct?
Yeah, that's correct. So we can map the solutions, the possible ways to implement business logic, to different types of subdomains. So for a supporting subdomain, we said that business logic there is more straightforward. So probably transaction script or active record is going to do the job there. Whereas a core subdomain is probably going to need a domain model or an event source domain model. Now,
does that really mean that domain-driven design kind of helps to answer the question how not to overcomplicate the software system?
Yeah, it does, in a sense, because as Eric Evans said multiple times, supporting subdomain is something that not risky from the business standpoint. The complexity is much lower than in a core subdomain. So you can use some rapid application development framework to implement it. Or as we said earlier, we can use it as a playground for testing out new approaches. Whereas core subdomain, this is where you want to invest your time and effort. This is where you want to use the most advanced tools. Now, these tools are going to be over-engineering for supporting subdomain. A generic subdomain, we already have an existing implementation. So trying to implement it yourself, whatever tool you choose is going to be over-engineering. Um, yeah, so domain-driven design helps us to find that balance, to design a solution that's not over-engineered and yet it's not under-engineered, but it should address the needs of the business at this moment.
Okay. So that means that domain-driven design helps us to navigate the talent inside the company. It will provide the guidance to the architecture patterns that we use there or there. What else can DDD do for us? So there's a term, this bounded context, and this basically, grouping the entities together that, solve pretty much the same business case. So how does this work in Dynamics?
Yeah, so we skip that important part of domain-driven design. So we have subdomains, which are boundaries of functionality of the business. And we have another type of boundary, which is called a bounded context. So a bounded context is a boundary of a model. And here it's important to define what is a model. Why is it so important in software engineering a process? So initially, we're talking about complexity of a business domain and how challenging it can be for a software engineer to get a grasp of it. We cannot expect software engineers to become domain experts in all business domains they're working on. Instead, according to domain-driven design, it's more beneficial to aim to build a model of the business domain. And that model is, it's a model. A model, it's not a copy of the real world, but it's an abstraction, something that it's not intended to copy that whole real world system, but provide you just enough information about it so that you can understand how it works, what it does, and to allow you to do your work. In our case, it's to implement the code for the system. So in domain-driven design, building models of business domains is one of the most important practices. Usually it's done by building what's called a ubiquitous language. Ubiquitous language is a language that you can speak with a domain expert about the business and understand each other. The important part is that you should be able to communicate with domain expert and to understand what they want, what they mean, and they should be able to understand you. That means that we cannot use technical terms. We have to focus on the terms from the business domain. We have to understand them. Again, that's not the whole field. You're not talking about becoming a doctor. But we do need to understand what parts of that business domain affect the system we're building. Because once we understand those concepts, we'll be able to implement that behavior of these concepts in code way better. Now, the example of a model from the real world that's not related to software engineering that Eric Evans used in his original book is a concept of a map. We have many different types of maps. We have world map, a map for navigation in sea and air, in underground, whatever. No map is ideal. No map aims to copy our planet Earth and provide you all answers to all possible questions. That's not possible. Instead, we have different maps that are more suited for different tasks.
Different models, basically.
Yes, exactly. We have different models. And that's the approach that domain-driven design uses for implementing software. Instead of trying to come up with one big overarching model of the business domain that's going to end up probably in, like those ERD diagrams spanning walls in corridors. People are afraid to look at, let alone to try to use them or modify them. So instead, we want to focus on crafting more fine-grained models that are suited to address different tasks. And that's where the notion of a bounded context comes in. A bounded context is simply the area in which a model can be used. In terms of software, this is a a component of a system that can use a specific model. In other bounded contexts, a different model may be more useful. So going back to Internovus, we had this notion of a lead. So when somebody sees an ad, they click on it, they see that landing page, and they decide to submit their information. We called it a lead event. For us, it was an event that somebody is interested in the project and they submitted their details, contact details. So that was a lead. Later on, we implemented that CRM system. And in there, we had a lead as well. But this time, it wasn't a mere event. This time, it was a very complicated business entity with a very complex behavior. So we have the same concept, but represented in different models, in different bounded contexts.
So
That's
you
why,
basically, yeah, you're using the same term, but for completely different things. And like what you're saying is that the areas where those terms mean those different things, those are bounded context, right?
yeah. We are, as people, we can deal with ambiguity. We can understand each other by using the context of the discussion, but computers code, not mentioning ChatGPT and all that stuff, usually it's not really good at it. That's why domain-driven design says that your models should be as straightforward as possible. Each term should have one and only one meaning. If you have the same term that means different things to different people, that's a strong heuristic that probably you have two models at play there, and they should be divided into multiple bounded contexts. And it can also work the other way around. You can find multiple stakeholders at a company using different terms, but they actually mean the same thing. Again, we cannot force them to use the same term because probably they have a reason for picking that terminology. So again, we're translating that language into a model and model into a bounded context. And bounded contexts are coarse-grained components of our system. So going back to the original question, how can we map the knowledge of the business domain to software design decisions? So now, once we took a dive into the business logic, we try to understand what's happening in those subdomains because we need to implement that business logic. We had to formulate a ubiquitous language. Formulating a ubiquitous language requires us to decide to divide that business domain into bounded contexts. So now we have those coarse-grained components that we can use for implementing the system. So a bounded context is a boundary of the applicability of a model, but it's also an ownership boundary. So it helps us to divide work between multiple teams. Only one team should own a bounded context. Because
okay, that's an important item, because typically what you have in a microservice environment is that, like, how do you assign the microservices to the different teams? So basically, you're saying once you understood the business so far that you can come up with a model, and you have a set of those models because you can't describe the whole business with only one, then you can divide the teams and services according to those boundaries.
Yeah, that's true. So bounded context is a boundary of ownership. No two teams can work on one bounded context. On the other hand, we can have a team working on multiple bounded contexts. That's okay. But in terms of knowledge sharing, we want to make sure that it is as efficient as possible. That's why domain-driven design says that, hey, no two teams should be able to work on the same model, on the same bounded context. Now, that provides us a whole other set of strategic design decisions that we can make, because these bounded contexts, they're not independent. They're part of a system. That means they have to work together to achieve the goal of the overarching system. And then we have different patterns for organizing how these bounded contexts can be integrated with each other. And that introduces in addition to the notion of business domain, that also introduces organizational constraints. how the teams who are going to implement those bounded contexts, how effective is their collaboration, their communication, or can they collaborate easily? For example, if one of them wants to change the integration interface, the second one will just, hey, no problem, we'll adapt. Or is it going to cause frictions and drama? And the first team will say, it's not worth it. We'll stick with the old inefficient model instead of going that direction. So for these cases, domain-driven design provides a set of patterns for different scenarios. And these patterns depend not only on the business domain, but also on the teams working on those bounded contexts.
Okay.
In short,
yeah, I have a next question. So imagine you have two teams, right? And one is dependent on another. And the first team is saying like, hey, we need those changes from your side, like add a new field or like change the semantics of the proper field. And the second team is saying like, hey, we're overloaded. We can do that for you. But if you would like, we will give you the access. You can do it yourself. But there's a problem here because like there's different domain knowledge, let's say. So how do you solve this, this kind of a situation? And how DDD actually guides us through that? Does it provide any, I don't know, patterns for that or technical terms or, I don't know, heuristics?
Yeah, so if you need the other team to implement a functionality for you, well, I'm afraid that we have no choice but to force them to do it one way or another. On the other hand, what if that other team exposes an interface that is just bad? That model that is being exposed through their boundary, simply inefficient. It's going to introduce a poor model into your code base if you will just conform to it. So for these cases, domain-driven design has a pattern called anti-corruption layer. And the idea here is that the consumer, the downstream service, can implement a thin proxy between them and the upstream, the service provider. And that proxy can translate the original model into a model which is more adapted for the needs of the downstream component, of the consumer. In that way, the model implemented in the consumer's bounded context is going to be protected from a bad influence of the service provider.
Okay, that's a nice thing. So the domain-driven design actually help you to use some patterns to avoid some kind of situations. Speaking about the anti-corruption layer, so Microsoft has a very good catalog of different patterns, and anti-corruption layer is in the list. If you want, after this broadcast, I will include this link in the description. But also, if you're interested in such kind of links, like you're on the channel with the Architecture Weekly newsletter, and the thing is that the link to this anti-corruption layer pattern was included in the latest 59 issue of this newsletter. So we're kind of lucky about that. So yeah. But yeah, let's go further. So we don't have a lot of time, and I still have a couple of questions to finish. So the first one is what is the biggest problems while adopting DDD? Because you can just, as a developer, you can just come to the company and say, hey, you're doing software wrong. This is the right way. So how do you adopt it in the large organization?
Yeah, so first of all, you can do it. If you are not planning to work there for a long time, you can do it. But yeah, that's a very, very hard question to answer, because you come to a new company and you cannot expect people to be proficient in domain-driven design. That's that ideal lab scenario. It's something that it's not going to happen in the real world. So that's why in my book, I have a chapter called Real World Domain-Driven Design, in which we get back to the ground that, okay, how can we apply this in the real world? And the thing is, it's really important to treat domain-driven design not as something magical, something that some magic does that you can pour over the code base and everything is going to be beautiful and your
Well,
design
I
is
would
just
love to
great.
have something magical, but
Me too. Yeah. So domain-driven design is something else. For that magic, we need to look elsewhere. Instead, domain-driven design is just a set of good practices that do have explanation. For example, if you're talking about an aggregate, if you read any domain-driven design book, you'll see that an aggregate is a transactional boundary. Now, if you come to someone in company and say, hey, from now on, we want to use the aggregate pattern. Here is a book about aggregates. Please read it. Tomorrow, the book will be there. The person won't be there. I know it from experience. So
okay. So you lost people to this approach.
I tried different ways of introducing people to domain-driven design. Some of them didn't work that well. I have to be honest. Yeah. So what you can do instead is make sure that you understand the reasoning behind each one of these patterns or practices provided by domain-driven design. These are the solutions. But again, as domain-driven design says, to design a solution, you have to understand the problem. So treat domain-driven design the same way. Understand what problem is addressed by each pattern or each practice. Now, once you have a good grasp of it, your life is going to be way easier because, well, at least I want to believe that people are rational. They want to do a good job. They want to be proud of their work. So if you understand the problems addressed by each pattern, you can use it for as a discussion to discuss this with other people. That, hey, these are the exact problems that we are facing right now with the solution that we have. However, there is another way of doing it. For example, the aggregate pattern or the bounded context pattern or whatever. But once you're using that problem you're facing as the basis for your discussion, it's going to be way easier to explain the need for a different way of doing things. Now, it's also important to keep in mind that domain-driven design, it's pretty wide methodology. It covers almost the whole development lifecycle. But incorporating all of it at once, it's not going to end well. It's not going to happen. Let's be honest about it. So instead, look for the Pareto principle, look for 20% of work that will provide you 80% of the value, and apply the patterns where they matter most. Start with something simple, for example, the aggregate pattern, the value object pattern, and advance from there. Once you have them in place, you can start introducing other patterns. And again, be patient with other people. Don't forget that it's not about preaching. Domain-driven design is not something that you have to believe in. It's something that you should be able to explain why each of the patterns from the methodology, why they're beneficial for the company, what problems they're addressing, and why these problems are important for you personally.
Yeah, unfortunately, you're saying that good things are coming with the hard work. So
just like core subdomains, you want competitive advantage, you have to deal with some complexity.
yeah,
No complexity, that's not core subdomain, that's supporting one.
Yeah, agree. Okay, we have a couple of questions from the audience, so thank you very much. First question is from Vitaly. So he asks if root aggregate equals boundary contexts.
Yeah. So bounded contexts, when we were talking about bounded context 20 minutes ago, we defined them as a linguistic boundary. We used the heuristics we're getting from cultivating a ubiquitous language for driving the scope of a bounded context. Now, if you follow these heuristics, you're going to end up with pretty coarse-grained bounded context. They're going to be wide. Usually, they will encompass multiple subdomains, maybe even one big bounded context. Again, if there are no ambiguity in the ubiquitous language inside of it, that's a valid bounded context. Sorry, you don't have to artificially force a decomposition. That's still in domain-driven design terms, that's a valid bounded context. However, since a bounded context is an ownership boundary, it means that sometimes we have to go further. We cannot limit ourselves to those linguistic boundaries. For example, again, in Chernovos, initially we had 2 bounded contexts, then 3, but at the same time we had like 6 development teams. So to follow that rule of no 2 teams should work on the same bounded context, we have to divide them further into finer grained bounded contexts. So you do need to find smaller boundaries for bounded contexts. So the next question is, what is the smallest boundary? The widest one is the linguistic boundary. That's the widest boundary possible. But what's the smallest one? And with the smallest one, it's the answer to that question is the answer we love to give, but hate to get. It depends.
As typical architects would say.
Yeah, it depends. So let me see if I can cover the topic, what it depends on in the time we have. So when we're looking at a system, whatever system we're talking about, we have components that work together to achieve the goal of a system. Now, bounded contexts are components in our software system. Now, in the system, we have 2 types of complexities, global and local. Local complexity is the complexity of the internals of a component. In our case, the internals of a bounded context. Global complexity, on the other hand, is the complexity of the interactions between the components of a system, or in our case, the interactions between bounded contexts. And the thing is, when you have the bare minimum number of bounded contexts, you're optimizing your global complexity. You're minimizing the number of components, so the interactions between them are going to be simpler. So global complexity is optimized. Local complexity, on the other hand, probably not so, because the bounded contexts are wide. So if you go to the opposite extreme, if we divide those bounded contexts to the absolute smallest boundary possible, and like Vitaly asked, that's probably going to be the boundary of an aggregate or a business entity. Depends how you're implementing the business logic. So if we are going to that route, we're going to end up with optimized local complexity. Our bounded contexts are really small. Local complexity is low. The complexity of the overarching system, on the other hand, it skyrockets. So we don't want to be neither in the first case nor in the second one. We want to balance these 2 complexities. So the optimal size of a bounded context depends on the system you are working on. In some cases, an aggregate or a business entity can be a valid boundary for a bounded context. In other cases, if you see that if you go that route of having those extra small bounded contexts introduces extra high global complexity, the interactions between them, then it's something that you probably would prefer to avoid. So you prefer to go.
Yeah. So you're saying there are 2 forces, like, so one is pushing out of, minimal context, making it wider in order to not to have like absolutely no complexity inside, and push from the other side, which tries to optimize the complexity of the whole system and decrease it globally. So basically, finding the balance between those forces will give you a kind of an optimal result.
Yeah. It's not easy. That's not something that, I can give you a formula. Here's how we do it. But that's what makes our job interesting. So.
Yeah. So that's a nice thing. Hopefully the architects will still have the job to find this balance, or maybe we'll be replaced with ChatGPT, which will just give us the optimal distribution of the bounded context in our system. So we'll see. Okay, thank you very much. Another question from Alexei is, did you have some problems with DDD? Like, let's rephrase it. What was the biggest problem with domain-driven design?
biggest problem with domain-driven design that I had a lot of them. If you read my book, the last chapter is a case study, my story of applying domain-driven design for the first time. You can read about all the problems I encountered, all the mistakes I did, and what I learned from them. It's there. Also, you can look for a talk that I delivered at multiple conferences called 7 Years of Domain-Driven Design. Same story, but in a different format. But these stories are more about mistakes that I was making as a DDD newbie. If we were to talk objectively about domain-driven design, I would say that the biggest problem with the methodology is introducing it. It is challenging. It's really it can be really hard. The larger the organization, the more experienced engineers are, the harder it is to introduce new ways of doing things. And, you know, hearing this is how we're doing stuff here, or this is how we always did stuff, it's not something that makes our job extra fun. But again, that's something we have to do, something that we have to invest in, our soft skills of incorporating these technologies, these new ways of doing things.
Yeah. Okay. Thank you very much. And the last question, I think, for today is from Michael. So he's asking, is there any research about the software tools or approaches that will help to find the optimal bounding context distribution given a domain model, like describe something somehow in a formal language or just, you know, in other way?
Yeah, and that's an interesting question. I'm afraid I'm not familiar with any researchers on this topic. However, as a part of research for my upcoming book on coupling, I had to read quite a few books and studies that were made on software design. And actually, there are studies that show that fractal geometry is a basis for good software design. If the code base is not fractal, if it misses a fractal dimension, that probably that code is not optimal. You can find a lot of studies that were done about it. If you want to look for it, look for scale-free networks in software design. That's a different terms, but the idea is still the same. So the idea is using fractals to tame complexity of a system. And in my upcoming book, one of the chapters is going to demonstrate how domain-driven design actually increases the fractality of the code base. So I know it's not a straightforward answer to your question, but that's the best one I have.
That's a nice clue. Thank you very much. So yeah, what we're going to do, we're going to include all the links that we were talking about today in the description below. So please check out, I don't know, tomorrow morning when I will be able to do that. I want to thank Vlad for coming today, speaking about domain-driven design and answering our questions. So thank you very much. Do you have anything to, you know, to wish to the audience?
To wish to the audience. May your code compile the first time and your tests pass the second time.
Okay, that's a nice one. Okay, thank you very much. Thanks again. Folks, if you like this thing, please leave a like down below. It really helps the channel. If you have any comments, you can leave them down there. And of course, make sure to subscribe because the more interviews are coming to the channel aside of the weekly newsletter. Thank you very much. See ya next time. Bye-bye.
Thank you so much for having me.
Okay.